Hi, my name is Connor Bruso, and this is my University of Notre Dame Summer 2012 research project. It's titled Expanding on Android 4.0 and Later Network Capabilities to Improve Bandwidth Consumption. So, as pretty much everyone's aware, the cost of modal data is increasing quite a bit. A couple years ago, you could get a unlimited data plan from your cell phone carrier for what, $20, $30 a month. And today, for many carriers, that's not even a plan anymore. You can't get unlimited data. Instead, it's the same cost, only gets you 2 gigs, 3 gigs, 4 gigs. And part of that is because so many more people have data phones today. So many more people are accessing data intensive applications and services that really put a strain on the infrastructure, especially during peak hours. And now today, that's not a huge deal. It's not like data is coming to a halt during peak hours, but as time goes on and the rate of data increases as it has been for the past couple of years, that could mean some serious issues in the future. So lately, that's meant a lot of research time has been gone into how to solve this problem, or at least how to alleviate it. And at the University of Notre Dame, a lot of work has been done on improving caching techniques, and on other ideas of how to just completely take data out of the cell phone and cell tower relationship. And so you're probably asking yourself, well, what does that mean? So instead of, let's say, you accessing CNN.com, and you get CNN.com, and then you go onto some other web page. And normally, within, say, if you're within a couple of minutes and you go back to CNN, that page comes up right away. And that's because that was cached. You've already accessed the data, and since you were within a certain amount of time, that's data stored and be pulled up right away. And that's great. But that's really only done for your phone. The question we're starting to ask now is, what if we can do that over a whole area of phones, a whole essentially network of phones? And that brings up a couple of questions. So say first let's air out how that would work. So let's go back to the same situation. If you're going to CNN.com, but you haven't been to CNN.com before, but you know what? Down the hallway in another classroom, someone else had just gone to CNN.com, and they have that webpage cached. Well, how about instead of you having to then get access your 3G or 4G and use the cell tower to get CNN.com, what if that phone could directly send those packets to you and relieve bandwidth from the cell tower? That would be huge, and if that could happen effectively over a host of phones, who knows how much data that could save the cell company from having to deal with. Of course, that's a great idea, but with a lot of research, the problem is, how can you implement it? To industry, a great idea is nothing if it can't be easily implemented, cheaply implemented, and quickly implemented. And so that's sort of where my project comes in. With the introduction of Android 4.0 Ice Cream Sandwich, there were a couple of network capabilities that were given to developers that are key to this idea. And one of those is something called VPN service. Android 4.0 introduced VPN service for the first time, and it gave the ability for a phone to create a VPN connection. A VPN connection is basically creating something called a virtual private network. A virtual private network is a network that connects remotely to a private network. An example of this is, say you wanted to do some work at home, and you had to access your company's internal network to get files or something like that. And essentially, you would create a VPN. So it acts like your computer or your phone at home is a part of that remote network. And that idea itself is not critical to this research, but what the VPN service does is it gives the application access to all packet information coming in and out of that phone. And that's huge. All it requires is the user to accept a VPN being created one time, and after that, it's pretty much good forever. And the app has access to all that data. So as of right now, as soon as that service came out, a couple of apps came out to help save on data usage. So they claim that if you install their app, you could cut down your data usage monthly and then hopefully save money on your bill. And one such app is called Innovo. And while researching Innovo, it was clear that it does cut down on data over time. But we had to ask, how did it do that? And so that's how we came across the VPN service in the first place, because when you install Innovo, first time you open it up, you have to agree to be creating a VPN. After doing more research, we discovered, and doing some packet sniffing, we discovered that all of the packets coming and leaving the phone once Innovo was activated were going to the same IP address. So, you're going to CNN.com, you're going to Google.com, no matter what you're doing, it's all going to the same IP address. And essentially that means is that Innovo has its own servers set up that are handling, basically acting as a middleman through the VPN to perform their own caching techniques, whatever that may be. It could be downgrading the quality of pictures on web pages, or whatever techniques they have, but they can do that through that server that you're connected to now. And so that was really interesting right away, because if we had the ability to see all of a whole network of phones packets, we could be able to tell who would access what, and then who could possibly be quote-unquote caching for someone else. And so that's a huge development. And while looking into the VPN service, I created a Linux server, really not unlike the one Innovo probably has set up. And then on the other side, I created an application for an Android 4.0 tablet to create a VPN and connect to the server. And so the phone was able to access its data like usual and access all its web pages, and meanwhile the server could see everything it was doing. Of course, that raises some security issues, but for us, it's important. It's important later on, and so that's like really the first part of behind our research idea of saving data over a network of phones. And the other idea is, if you remember, is how can we get the data from, or how we can get those packets from one phone to another? I mean, it's not like in the past there were just phones that were instantly connecting to one another and that could just send things between one another. Well, with Android 4.0 and after, Wi-Fi Direct was introduced. And Wi-Fi Direct is a standard that allows different devices, not necessarily phones, to connect with one another without a wireless access point. So essentially, say you wanted to print out something to a printer, you didn't have to be on a network with that printer. You didn't need a wireless router. You could just directly, hence Wi-Fi Direct, connect to the printer and print out whatever you needed. And so I had to do research on Wi-Fi Direct and see how it worked in Android, and it essentially works like any other server to client relationship. It creates a socket and a connection between both phones, and any byte data can be sent between them as long as both phones are compatible with whatever's being sent. And this is huge. It basically it's the exact solution for what we need to get packet data between one phone and another. Because what you could do is create the one phone that's sending the cached web page would become essentially a server, and then connect to a socket on the other phone and send all the byte data, the packet data over. And this is great. And so combining those things, we can essentially, one, see all packet data in a network of phones, see which ones have accessed what, and because of that, then you could use a certain phone in that network send the web page it's already accessed to another phone. And this is great. And so while this is great and while this is fairly easy to implement, because it can be pretty much done with one app installation. Once these ideas are combined with one app installation on a phone, and that would take 2 seconds, and all someone would have to do is agree to a VPN to be created, and that's fantastic. But as of right now, there are some limitations, and of course that comes down to Wi-Fi Direct is still a standard that requires quote-unquote pairing. For anyone who has a Bluetooth device, you're familiar with what pairing is, because if you pair a device, both devices have to agree to the connection being made. So if you're connecting your mobile headset to your phone, you have to first probably press a button on the mobile headset, and then on your phone you have to agree to that connection being made. Of course, you can probably see why this is really inconvenient if you want to be sending data between phones. If you want to access CNN.com and some other phone has the data stored already to send over to you, you don't want to have to wait for that person to agree to send the data over to you. The idea is that this just happens in your pocket without anything, without any interaction, hence being easily implementable and easily used by the common cell phone owner. And so that is a limitation right now. Without that, it would be the perfect solution. And also, VPN service is still it's really a new concept to cell phones and Android. So as of right now, this would only be possible on an Android phone. And also, we're not entirely sure how VPN service handles upgrades. So whenever we would have to make a change to the application, we would have to send that out to all phones. We don't know if that would make all the VPN connections break down, and then you'd have to reconnect again, because that could be a huge problem if you suddenly have 500,000 phones trying to connect, create a VPN at the same time. That could be a serious problem. So definitely a lot more research has to be done on this, but in the future it's definitely a viable solution to saving bandwidth and could certainly help the mobile telephone companies.